Hello students, I hope you're all doing well. This is the last day of notes for Chapter 5. This is actually 5.5 and 5.6 together. And you're going to start off with factoring the polynomials. So if I look at number 1, there is no greatest common factor. So I'm going to go right to my normal factoring method. I put my first term in my first box, the last term in the last box. And then I multiply those two terms together. So we get negative 168x squared, and we're looking for factors that add to be 13x. Alright, so thinking about that, this one might take you a little bit longer to come up with those numbers, and that's okay, but negative 8x and 21x fit the bill. They will multiply to be negative 168x squared and add to be 13x. Okay, and from there we can take out our greatest common factors. These both divide by 7. These both divide by 2x. And then vertically I can take out a 3x and a negative 4. Again, don't forget your negative because that edge is negative. So this factors as 2x plus 7 times 3x minus 4. And we're going to set those both equal to 0. So here I'm going to subtract the 7, so 2x equals negative 7. Divide by 2 and we get negative 7 halves. Here we're going to add the 4, so 3x is equal to 4. And when we divide by 3, we get 4 over 3. Alright, I got two solutions. I'm going to look back and see if that makes sense. The fundamental theorem of algebra tells me the power, tells me how many solutions I'm going to have, and so I have two solutions. Alright, looking at your second warm-up problem, this time we have a fourth power, we have a quartic, and I'm looking for factors that multiply to be 20x to the fourth, that will add to be negative 9x squared, and so we can use a negative 5x squared and a negative 4x squared to factor. And so we get factors of x squared minus 4 and x squared minus 5. And we need to factor and find the zeros. So from here we have x squared minus 4 and x squared minus 5. Now we could solve from here from square rooting, but I just want to point out that x squared minus 4 is your difference of two squares, which is your x minus 2 and x plus 2 pattern. 5 isn't a perfect square, so we can't do that with a 5. And so if I set my factors equal to 0, I should get 4 solutions. X minus 2 equals 0, so x equals 2. X plus 2 equals 0, so x equals a negative 2. X squared minus 5 equals 0. And so if I add my 5, I have x squared equals 5. And remember, when you solve by square rooting, you need plus or minus the square root of 5. And because it's plus or minus, that's 2 solutions, along with the other 2, gives us all 4 solutions. Alright, so that is your warm-up. You can stop and pause here if you need to look that over again. The new thing for today is the rational zero theorem, which tells you that every rational zero, and remember a rational number is just a integer, so a positive or negative number over another integer, it's going to be in the following form, which is P, which is the factors of the constant term, over Q, which is the factors of the leading coefficient. And once you have that list of possible rational zeros, then you can test them using division, or you can look at a graph and see which ones make sense so that you can factor and solve all the way. And so this is why we do the polynomial division, is because not everything can be factored. And so in that case, we have to use either long or synthetic division to get it down to the quadratic formula, which has to be a quadratic. It has to be an x squared. Okay, so looking at the first part of the notes, this is like the first part of your homework. You're just going to list the possible rational zeros. And so remember, P is the factors of your constant term, so P is going to be factors of 16 or negative 16. And Q is factors of the leading coefficient, and so that is factors of 12. So if I think about P being negative 16, the factors would be plus or minus, either positive or negative. 1, 2, 4, 8, and 16. These are all the factors that multiply to be positive or negative 16. And for Q, we have the 12. And so the factors that multiply to be 12 include positive or negative 1, 2, 3, 4, 2 and 6, and 1 and 12. And so our possible rational zeros are all the p's divided by all the q's. P divided by q. So that's going to be plus or minus, and I'm going to do every single p divided by every single q. So all of these numbers divided by 1 are just those numbers, 1, 2, 4, 8, and 16. Okay, so 1 divided by 1 is 1, 2 divided by 1 is 2, 4 divided by 1 is 4, 8 divided by 1 is 8, 16 divided by 1 is 16. Then we are going to have 1 over 2, so all of these numbers divided by 2, so 1 over 2, 4 over 2, 8 over 2, and 16 over 2. Now, if any of these numbers are already in the list, you can cross them out. So 1/2 is not already in the list, but 4 over 2 is 2, and that's already in the list. 8 over 2 is 4, that's already in the list. And 16 over 2 is 8, that's already in the list. And then we do all the numbers over 3, so we have 1 over 3, 2 over 3, 4 over 3, 8 over 3, and 16 over 3. And none of these numbers are already in the list, so I can't cross any of them out. And then we put all the numbers over 4, so we have 1 over 4, 2 over 4, 4 over 4, 8 over 4, and 16 over 4. 1 over 4 is not on the list, 2/4 is 1/2, we already have that. 4/4 is 1, we already have that. 8/4 is 2, we already have that. And 16/4 is 4, we already have that. Alright, so we're going to keep going. We have everything over 1, 2, 3, and 4. Now we're on to 6, so all of these numbers over 6. That's 1/6, 2/6, 4/6, 8/6, and 16 over 6. And again, I need to look and see if any of these numbers are already in the list. 1/6 is not, 2/6 is just 1/3, we already have that. 4 over 6 is 2 over 3, we already have that. If we simplify 8 over 6, if we divide by 2, that's 4 over 3, we already have that. And again, if you divide by 2, 16 over 6 would be 8 over 3, we already have that. Alright, last time around, we're going to have everything over 12. So we're going to have 1/12, and then 2 over 12, 4 over 12, 8 over 12, and 16 over 12. Okay, that's the whole list. Again, I'm going to look and see if I have any repeats. So 2/12, that'd be 1/6, we already have that. If we divide by 4, this would be 1 over 3, we already have 1/3. If we divide by 4, this would be 2 over 3, we already have 2/3. And 16 over 12, if we divide by 4, that would be 4 over 3, we already have 4/3. So now we're going to write our list of actual possible zeros without all the numbers that are crossed out. So our list of possible rational zeros, you need the plus or minus. That's a common quiz mistake, is to forget the plus or minus. 1, 2, 4, 8, 16, okay, 1/2, 1/3, 2/3, 4/3, 8/3, 16/3, 1/4. These are all crossed out. 1/6, 1/12. Alright, and I'm not forgetting anything. So that's our list of possible rational zeros. And you will have a question on your test and on your quiz about how to find the list of possible rational zeros, and this is your process. Listing all the factors of p and all the factors of q, and doing every p divided by every q. I'm going to stop here before I go on to the back page.